All right, are you ready? It's time for the biggest idea of the whole course in like the second week of the semester. But it's one big idea that changes the way we think about the rest of the tools we're going to see. It changes everything. It's just a small turning in place. It's just like seeing the problem in a slightly different way that completely transforms the way we approach modeling and in a way that really will result in better overall outcomes in big data scenarios than in small data scenarios. So let's put this in a little bit more context. In a small data, classical statistical context, we have very limited data. Like it's expensive to take, it's expensive to manipulate, it's expensive to curate. It's just a pain to get data. And therefore, we want to explain by creating a rule why our dependent variable depends on the independent variables, the xi. And because we only have so much data at our disposal here, we judge a model by its ability to explain the data we have. It's not like we're going to go out and collect more data. It's just too expensive to do that. And so we talk about overall model quality with things like R squared, like the goodness of fit. Maybe we get it to adjusted R squared or something like this in terms of linear regression. But the big idea is that we judge a model's quality by its ability to explain the data we have currently collected, because it's not like we're going to go out and get more. It's just too expensive to do that. Like the data we have are all the data we're going to have, and we want to make the most of those limited, scarce, precious data points. In a big data context, it's kind of exactly the opposite. Like data typically are not a problem. Like we typically have many more data than we know what to do with, many more data that we can possibly deal with at any particular time. So to do this, well, because of the abundance of data, we can kind of, what's the right way to put it? Kind of like raise our sights. Like we can be more ambitious. And so rather than creating a rule to explain how y has depended on the x's in the past, we're actually going to try to predict the future. That's really what we're trying to do. This is the big difference. Rather than explain the past, we're trying to predict the future. And because of that, if predicting the future is our goal, then to assess model quality, we really need to have like an assessment of this. Like how well can this model predict data points that it's never seen before? Like this new data. Like imagine I built a model on some data and then I went and collected a new whole data set and then I said, okay, model, how well do you predict these future data points? Like, can you actually predict the future like you said you were going to be able to? Or do you do very well on the data you've seen before and you fail spectacularly perhaps on the data you haven't seen before? And so let's walk through how this impacts our data analytic tool flow. So this is the flow we will be going through for the next 10 weeks or something every single day, because it's the same conceptual, like what we're seeing here results in the same conceptual changes in every single model type. There's no difference. So here's the big idea. We take our overall data set, which is represented by this big circle, and we break it into two pieces, training and test. We build our model, we generate our model based on only the training data set. We take only the training data set points, we build our model. So we train our linear regression, we build our linear regression, for instance. We then take this model and we apply that model to the test data points. We see how well the model will do in predicting these test data points, which it did not see during the generation phase. So we build the model on training, and then we evaluate the model's performance on test. By doing this, we give the model a true simulation of what it's designed to do, predict the future. So in some sense, the training data set is like our past data set. The test, which is sometimes called the holdout, this holdout or this test is the simulation of the future, because the model has never seen these data before. It really is like these, like we went out and took these data sometime in the future, and now the model has to try to predict it. The model doesn't know that we had all these data to begin with, and then we set some aside. Like as far as the model is concerned, these data points really were collected completely after the model generation phase. So training is old data, is past data. Test is our simulation or our simulacrum of the new data, the future data. And by building the model on training and evaluating the model's performance on test, we get an accurate representation of how well this model might be expected to perform when, for instance, we put it out on a server, that's bidding on used cars. Or we put it out on a server that's deciding on which banner ad to show our users. We put it out on a server deciding whether to bid on a particular asset on the stock market. so on and so on and so on. We get an estimate of how this thing might perform out in the wild, and that's ultimately what we want. So like I said, we're going to be doing this process a bunch, like a bunch, every day for a very long time. But it does drive the point home just how important it is. And we'll talk about, you know, various pieces here and like how big these things should be. There's a lot to unpack here, but this is the overall idea. So stay tuned for more content on this.